Okay, welcome. So this is about one of the project implementation. So I think you need to see the previous videos. Yeah. So this video will be very short. It will be just some uh, code cleanup. I think one file is having something that it is not supposed to have, those kind of cases. This is not an important video. I'm just recording. Oh, yeah, it will not be a useful video for sure. Yeah. So this is the paper on stock price prediction that I'm trying to implement, right? Yeah. I believe there are 8 different videos before this, or 8 steps before this. Yeah. So okay, I believe you see the on Google Chrome, the Jupyter notebook. Okay, cleaning, right? As I told, I think one file has code that is not relevant, or the purpose is different, because there is one file, then I created multiple copies to repurpose it for a different thing, right? So I need to remove the additional code. I could keep it, but there is no point. Anyway. Okay, let's see. My video is not really that important, and this is Said Ahmed from Toronto, Canada. Okay, so if I go there, so Pearson is what I started working on. Okay, it's just the Pearson correlation-based graph creation. Let's see, I go to Spearman. If I go to Spearman, then, okay, I think this is the YouTube channel. So here you will see, yeah, step 8 that I'm just uploading. Anyway, Spearman, right? Okay, in this video, what I can try to do, I can try to take this, I think, financial news-based graph creation, and using that graph for price prediction, I can just do something on that part as well, right? So that way, this can be an important video as well. Okay. So let's say kernel, restart and clean. Yeah, because I will be cleaning up, just I'll be checking and cleaning. So import libraries. Okay, let's see. I probably can take it here, here, and mark down, right? So import libraries. Okay, this is for the graph, GNN and GCN related. That's okay. This is machine learning. Machine learning, deep learning as well, right? Machine learning. That is the standard ones. Those are some specific, right? Graph. Drop rows with, I think the purpose was, do we only work with rows that does not have any null values? That's what it is for, right? But actually, we will not use anything. We'll be treating null values before coming here, or we'll be just taking only those rows where there is no null values, because the stock market prices, those sequential or everyday price, we wanted to make sure that the price date range that we take, where, okay, for different stocks, we take date range where the data is there for all of the stocks for the date. And in that way, we'll be removing most of the null value related cells, but still we'll do further treatment. And then, so in that way, in general, we'll not need this. Okay, it is the merged data that we are working on. It is a small stock price, all merged. Okay, it's just 10 stocks here. Eventually, we'll be working with 30 or more stocks because the paper is 30, but there might be different companies, right? So, okay, so what I need, I just adjusted close. That's what I need. Okay, I wanted to adjust it close. No, that is not the right thing because it is supposed to be approximated like this. But okay, this is something one thing that I need to fix. If adjusted close significantly differs from close, then that's not what you want to uh, what we want to work with. Okay, so in that case, we might only on the closing price. Okay. Okay, sort by. Okay, I don't think this may not be the best approach. In one of the files that I have used a different approach for sorting by the dates. Okay, sorting by the dates. In that case, dates are here stock price. So yeah, sorting by dates will apply to all of the stocks. That's good. But I need a different approach for this. But this particular things, it, it is not a good idea. Another thing is actually I need to, when I'm using this, when I'm creating this file, so I can just sort it uh, there as well. So let's say, think for sorting. Okay, let's see. So date to CSV, right? When I'm merging, yeah, I did some date related treatment. I'm just trying to see where exactly I did it. It is supposed to be in this file. Okay, yeah, this file it will be. Okay, now I think it probably is better that I sort the files when I create the file, right? When I create the master file, I can do it and for precautions. One more time I can do. There is nothing now, but it is just takes more time depending on the data context. You can use some verification methods. Let me see. So did I fix it for? Yeah, I might have used some sort of sorting here as well. Okay. Okay, for now keep it. As long as I do the sorting thing in the while creating the merge data set, that should be good. I think the reason I'm wondering because sometimes if the data is not in the correct format or the format is related methods by default expects, it may not get correct output. So okay, because if we merge the data correctly, then we probably don't need to sort it again. But let's keep it for now. Yeah, that's you can see it right. The error is here. It's warning. So here, let's see each row. I think for a particular stock, we have data in multiple rows, but we don't want it, right? Either we want ticker, all the prices goes this way. Okay, looks like sometimes my video is important, right? Because if I explain something, I probably using some body language. So yeah, what I'm telling, Here, one ticker, one day price, another same ticker, another same ticker, another price, right? But if you do the ticker, stock ticker, all the price one date after another that go to one, right? Or probably the stock ticker here, all the prices date by date, each date that works here, but it is not the same format. So I need to some pivot around this ticker, right? There are cases when this may work and this may not work. For now, keep it like this. Okay. So this correlation, that is just the Pearson, but we are in the spearman, so remove it. Okay, this is one format. One of this format is okay, but I believe the stellar graph eventually takes this format. Drop with, yeah, you can see lots of non-values. We'll not use it. We will not use it that much, but let's say uh, just for the sake of drop rows. Okay, it is supposed to be executed there. So you can see there is no null values, but it does not mean that uh, this data is good, because we need the data for a particular period and for each day and for all stocks, right? So that is further verification. Just the dropping is not enough. Okay, this is not important, or it may or may not be there finally, but let's keep it like this. Okay, it probably hasn't initially I wrote it, but okay. So this is spearman, so Pearson correlation, we'll remove it. Pearson correlation based graph, I will remove it. Spearman correlation coefficient. Yeah, as a software developer, we probably like a little bit of more space, especially here, not around. Okay, it is from that paper. They tell if the correlation is greater than 0.4, then create an edge between these two stocks. Otherwise, don't. Spearman, right? Kendall. Let's remove Kendall. Okay. Now I will be using network X to create the network X. We'll need it. The library. Spearman and Kendall. Pearson, I don't need it. Kendall, I don't need it. So network X, graph Pearson. Okay. We see just two of them are not. Yeah, I believe when I tried all the different stocks, then I could get a better graph. Better graph means it looks like graph. The thing, not everyone has connection to everyone. Especially if you plot the financial news, then that can be uh, even better. Let's say financial stock tickers. Let's say kernel, student, run all. I'll try to see if I try to draw a graph, financial graph. How does it look like? Which one I run? Okay, that's good. So I'm working with the Okay, rather than making one cell, let's do it there. Okay, spearman, right? Spearman. Yeah, I actually prefer a little bit for my eyes. Okay, yeah, I think when I might have taken a little bit of sample line of this draw network X from network X library examples, I may not have adjusted for the spaces. So it's like this. I don't need this. Okay. Yet GCN layer Pearson, right? Actually, I need to do it spearman, right? DFS transpose. Okay, in terms of name, they're very similar. I mean, the Pearson code and here, I try to be consistent in the naming so that if I just change the Pearson to spearman to Kendall, it more or less will work, right? Let's see. So I need to work with now spearman. Yeah, I'm finding out all the nodes and edges in this graph. Pearson edges, I think I better replace it with spearman, right? Yeah, I believe this one has also find and replace. Yeah, for sure used it, right? You can use that as well. For now, let's spearman edges, data spearman edges. It does mean that we have the edge weight as well. Let me grab some more water and come back here. Okay, so actually we really will not be using this. Even for Pearson, this is not what we'll be using. We'll be, I think initially I just tried to create some sort of experiment so that I can at least create a graph, right? Because it seems creating node data seemed to be difficult. There are some other things needed to do. It was just some initial version. Yeah, structured the. So I don't think I need to keep it that much. Okay, let's just keep it so that if okay, yeah, find replace, yes, that is ideally better. Let's do it rather than doing it blindly, just doing it. Okay, replace all in general is not a good idea because as far as from my experience, replace all can replace some good part and corrupt your code because you actually don't know what you wrote where for what purpose. If you wrote it somewhere earlier, you must have forgotten. As part of the node, okay, so this part, this is the important part, so it's better that I highlight it, right? So DFS transpose, just trying to see what is in the transpose so that I can take it from there. Yeah, I needed to little bit of tweaking, spend some time in this block to get it right. Eventually, it worked. So this is just one of the stock fallacy. Structure the feature matrix. It's storing the feature matrix to the so that it can be passed to the GCN all node data. Okay. It will be spearman. Yeah, we are taking this data into a data frame. Now we create a stellar graph where we will be passing this node data and edge data. Okay. The features, weights. Okay, this is for to pass as part of the graph convolutional neural network. Full batch generator. Okay, so edge and node. That is enough. One thing could be spearman edges with features. Okay, let's remove it. If we need to write any such code, we can write them easily, right? So this Pearson it will be spearman train subjects, train test split, spearman. This probably was there just to debug. Okay, just a sample model, GCN model. You can see it, I think, in the examples in the GCN related libraries. So usually classification is more common in the examples. So let's keep it here so that we say that this is how the classification works, but ours is the regression problem, so I'll not remove it, I'll not use it, I'll not remove it, just keep it there. Okay, now the model and the corresponding things. Okay, let's see. Okay, now the GCN layer and the prediction layer. GCN has multiple layers for these things, these layer sizes. We're sending to the predictions. Okay, in the paper, they tell GCN layer and the CNN layer, then GCN layer and the CNN layer, right? So we are not doing it that way exactly. And in that case, the paper tells GCN works with the node structure and CNN works with the node features, right? So we need to do some little more there. For now, keep it like this. Let's use some dropout. Okay, experiment with models. This was just a different variation trying to use the CNN. Let's not worry about now. I just wanted to make the code a little bit of in good shape. Okay. Okay, this probably was some experimental code that I was thinking, okay, just experimental code. I believe it is from internet. Yeah, I think this making the CNN and GCN working together, there is a little bit of trick so that the output and input dimension matches and all those things. So I still need to do some sort of exploration to make things right. Okay, for now, because that's not really part of the code. So let's the example in the example. Okay, yeah, it is also as part of the exploration, right? I think how CNN works, right? This is the CNN dataset and CNN stock prediction. It is from there, but that was for the experimental purpose. And I thought, okay, if it works, then I might use some ideas from there. Okay, now let's see. I think it just uses CNN to predict stock prices, right? CNN to predict stock prices. It is not using our data set. It is just using some example data sets. So I probably will mark it as an comment block. I actually took this out in another time series CNN, right? That was some exploration with CNN, how it does with some stock price prediction. That is a different thing. So after I have a after I explore it, then I will see if that thing I can combine with the with our GCN, right? At this point, the GCN, it does not divide the data in multiple 3-time step or 6-time step things. It just works in one time step ahead and predicts for each subsequent time step days, right? But 3-time step ahead or 6-time step ahead, there's a paper did also. Paper did 1-time step, 3-time step, 6-time step, right? So in that case, this example may be helpful, but that's using only CNN. Now I need to use CNN or GCM. There are some tricks. So initially, my goal is to see how things work and then try to glue them together to work together, right? That's how things it is. Okay, if I took models, at this moment, this model will be the experimental model. So let's the experimental models. I don't want to use the experimental model, so I'll re-execute this so that this becomes the model. This otherwise this was supposed to be the model. The second one was GCN, CNN, and perceptron, right? The previous one just GCN and MLP. So I'm using the GCN and MLP because this CNN thinks it is not aligned with the way the problem wants it. Okay, not my code that, but okay. So the model input will be coming here, output will be in the predictions. We're compiling. So the model summary looks like this. Okay, how many epochs? At this one, I'm just clearing code, so I'll just see what is going on there. Whether the prediction is correct or not, but still. So mean squared error, loss. So that's just to show the, okay, this Pearson thing is not supposed to be here. Right. Okay, all predictions shape. Yeah, this is the two thing that is important. It probably just for going back and see what is in the data. Data means the prices, just to visually check, compare the predictions and the originals. Okay, this is just giving the shape, right? Let's see. Yeah, at this moment, it does not look like they match. And we also need to see hot column and how they actually uh, are being used. In general, it is supposed to be okay, but anyway, that probably is for further verification. Okay, too much output. Let's generator and this prediction. Yeah, this is the paradigm, right? This is the okay. So I can see that Pearson to spearman conversion code is there. Let's see. Okay, it's a Pearson correlations, some library method, spearman. I really not need it. Okay, better to remove all the Pearson thing, whether uh, still part of the code or commented, because sometimes I might just uh, activate this code or take some from here to the other places that may still have the word Pearson, but I may not see it that well. Anyway, it looks like we'll be more or less clean. Okay, for this one, I will implement it in the merging, the sorting, so that I don't have to deal with it here. Okay, now I'll do the same thing for the uh, Kendall tau, right? Kendall tau. So now I will have three different files: Pearson, Spearman, Kendall tau, and then the financial news. Uh, okay, if I get all those, then I'll be focusing more on the GCN modeling and all those things. Now, still one more thing I will need to do. I'll need to find out the range of the dates where all of the stocks have data for all of the uh, possible days. Okay, I don't think I need to show you the Kendall tau. I can just do it on my own and upload. Okay, we have a GitHub for this project, but I may not always update. I think I can definitely upload by end of April. Before that, I may or may not upload it there. Okay. Bye.